Hello everyone. Today we're going to be talking about the structure of the atmosphere lesson in our booklets on weather. So of course the atmosphere is very important to weather. It has several layers. Some of those layers more important to weather than others. The four major layers are the troposphere, the stratosphere, the mesosphere, and the thermosphere. You can see those laid out for us on the right. The thermosphere is closest to space. Mesosphere is a little bit closer to us. The stratosphere is even closer, and then the troposphere is the layer that is closest to the ground. In between those layers, there are also the tropopause, the stratopause, and the mesopause. And I believe that we are missing one label here. So if you can just drop this onto your copy at home, we can drop in the stratopause right in here. Okay. Just make it a color you can see there. Okay. Stratopause. So each of those pauses lies in between the other layers. These transition zones are layers of air that have constant temperature. Meanwhile, the other zones or the other regions, those regions have a changing temperature. So it's at the point of the mesopause where the temperatures are mixing. You can see the temperature curve is this yellow line here. So you can see how the temperature as you go up into the tropopause, you get a very low temperature as you get up into that atmosphere there. That's right around where the clouds form. And then as you move along the stratosphere, you'll get to the stratopause, which for some reason has been cut out for whatever reason. And you end up with a little bit of a higher temperature, closer to 0. And then as we go to the mesopause, we go through the mesosphere, you'll see a cooling down of the air, followed by a point of inflection here at the mesopause. And then the air starts to increase in temperature as we go towards space. And that might be confusing to you, but I'll discuss that in a second about how when you get close to space, the temperature of the particles is actually quite high. It's just that there aren't very many particles there. So let's talk about these as we go here. So in terms of weather, essentially all of Earth's weather occurs in the troposphere. This is the phase that's closest to us. The first 10 kilometers of air above the Earth's surface. The bottom of the troposphere, which is where we live, has a temperature between 40 degrees Celsius and 35 degrees Celsius, depending on the geographical location and season. In other words, notice that this minus is moved. I was like, wait a second, Winnipeg is not included in there. This is negative 40 degrees Celsius. So between negative 40 degrees Celsius and 35 degrees Celsius, on average around the world, there certainly have been examples in Winnipeg even where we had much lower temperatures, or at least it felt lower than 40. And of course, there are other places where it feels higher than 30, but that might be a combination of humidity and other effects. In other words, the temperature at the bottom of the troposphere is essentially our ground temperature, the temperature we experience every day. The top of the troposphere maintains a relatively constant temperature of minus 57 degrees, and that's of course where you're going to reach that tropopause. And that tropopause is where the temperature is going to be constant. So let's put a little note here at the tropopause. Okay, the stratosphere starts above the tropopause at about 23 kilometers above the Earth's surface, and it continues to about 50 kilometers above the Earth's surface. Those numbers might change a little bit depending on your resource, but those are the numbers we're going with. And I'm more concerned about you knowing the order of the regions as opposed to the exact numbers anyways. The ozone is found in this layer, the stratosphere, and that ozone layer that's found there absorbs ultraviolet radiation. as that ozone absorbs the ultraviolet radiation from the sun, the absorbed energy causes the stratosphere temperature to increase. So as you move through the stratosphere, you'll find that the temperature is increasing as you get higher up, closer to the sun. And that's where you're going to have more ultraviolet radiation being absorbed. So the stratosphere temperature changes from that minus 57 we discussed earlier up to minus 2 degrees. So again, we have to put a little negative there. It seems to have shifted away, disappeared on us. So minus 2 degrees. The stratopause is another transition layer where we have some uniform temperature at that minus 2 degrees a level. And then we're going to start moving into the mesosphere. Mesosphere is 60 kilometers above the Earth's surface, and it extends to upwards of 90 kilometers. And as you go up, its temperature decreases again from minus 2 degrees to minus 90 degrees. And so it gets colder and colder. Again, there's another transition layer at the thermosphere, and that layer extends from an altitude of about 90 kilometers to 100 kilometers, and it has a uniform temperature about minus 90 degrees. And that would be the mesopause. After the mesopause, we have the thermosphere, which is called the thermosphere for its very high temperature, except that we have to separate again the idea of temperature. Temperature is a measure of how fast the particles are moving on average. It's not a measure of how many particles there are. It's not even really, it's a degree, we have used the term degree of hotness, but in a way, it's not hot like you would feel. When we feel something is hot, we are feeling many particles with lots of energy hitting your hand or hitting your sensor all at once. But in the case of space, which is where the thermosphere really extends, it extends right into space, there aren't a lot of particles at that point. The air density is very, very low. And so this low density air doesn't really have much, it won't feel very hot at all. It will instead just, the particles, if you could catch a particle, you would find that it's moving very quickly, but there just aren't a lot of those particles flying around. So it won't feel warm, but the temperature is high because the particles are moving high because they're absorbing a lot of the sun's energy. This is similar to how when you have an oven and it's 220 degrees Celsius inside that oven, you can pretty much stick your hand in the oven. It's not until you really contact something inside the oven that you actually feel the heat of that oven. If you just stick your hand in the oven while it's 220 degrees, stick your hand inside the oven and without touching any surfaces, your hand won't actually start burning and you won't get a burn right away. You might feel some warmth. Stick your hand in a 100-degree pot of water where there are many, many more molecules, your hand will be scalded immediately. Even though the temperature is higher for the oven, the air is lower density, and so there's less molecules hitting your hand at a given time. So I'll leave you there to think about that. We have a video posted from I believe it might be a Dr. Dave video or something like that will come up in your stream. Please follow that video about the atmosphere and all of the different layers with more detail than we've done today. But we'll talk to you soon and with the next lesson. Have a great day.